Good day everyone. Today I'm back again. We are going to discuss linear inequality today. The word inequality stands for an expression that compares two statements and indicate that these two statements are not equal. And what it means is that when you have something like this, if I say that A equals B, it means that the content of A is the same as the content of B. Whatever A is what B is. But when I write it this way, it means that A is not equal to B. And when A is not equal to B, that's what we refer to as inequality. If A is not equal to B, it simply means that it is either A is greater than B or B is greater than A. So we have four signs we use to represent inequality. First, this sign stands for greater than. This one stands for less than. Okay, to remember that we use our right and left hand to represent it. Conventionally, majority of us, except you are left-handed, you know that you work most with your right hand, and because of that, the right hand is stronger than the left hand. So the right hand stands for greater than, the left stands for less than. You can see it if I place my right hand like this. You will see greater than, and then this other one less than. You see, very simple to remember. So we also have greater than or equal to. We have greater than or equal to. We also have less than or equal to. So these are the four signs we are going to be using to solve questions. In linear inequality, most of the things you are going to do, you realize that there is no much difference between linear inequality and linear equations. When you are asked to solve and find x in your linear equations, you try to make x up to the formula and you get an answer. That same process we are going to follow to use these inequalities. They are just slight differences that we are going to identify while we solve questions. So as we have identified these four inequality signs, we are going to use them and see what it means and what each one of them represents. Let us look at a few questions so that we can understand better. So if I am asked to solve this inequality, if it is an equation, we try to collect like terms. We try to collect like terms and make x up to the formula. The same thing we are going to do. We have 6x minus 2 is less than 2x plus 8. So what are we going to do? We collect like terms. We can now say 6x, because 6x is here, 2x will move to this side to meet it. You know that when a number or a variable is crossing the sign of equality, it changes its own sign. The same thing happens when a number or a variable crosses inequality sign, it still changes its sign. So 2x is crossing because it's positive here. When it crosses to this other side, it becomes minus 2x is less than 8 is here before. Minus 2, when it crosses to this other side, it becomes plus 2. And then we have what? 6x minus 2x, we have 4x is less than the same sign. 8 plus 2, we have what? 10. And then what do? You divide both sides by 4. So you have 4x divided by 4, so that we can find x is less than 10 divided by 4. 4 here will cancel 4 here. That means x is less than 2 here will give us 5. 2 here will give us 2. X is less than 5 over 2, which means that x is less than 5 divided by 2 will give us 2.5. What this thing means is that x is a range of value that is less than 2.5, like 2.4, 2.3, 2, 1, 0, minus 1, downwards. It's unlimited, but it should be less than 2.5. Any value less than 2.5 can fit in as s, and that is what this expression means. That is what it means, and you can see how simple it is, just like linear equation. Okay, let's take one more example. Okay, looking at this other question, this is 2x plus 5 over x is less than or equal to 2x over x minus 3. If this is an equation, what we will do is to cross multiply in order to clear the fraction so that it will no longer be a fraction. We'll do the same thing. We cross multiply. So we'll multiply this and this and multiply this and this. So when we do that, this times this, we are going to have 2x plus 5 times x minus 3 is less than or equal to, this will multiply this, 2x times x. Okay, then we simplify. 2x times x, we can open our bracket, we have 2x multiply x minus 3, as this will multiply this, plus 5 multiply x minus 3. Okay, it's less than or equal to 2x times x, you have 2x squared. Okay, 2x times x, you have 2x squared. 2x times 3, you have minus 6x. 5 times x, you have 5x. 5 times minus 3, you have minus 15, less than or equal to 2x squared. We collect like terms as we usually do. This is x squared, this is x squared. So we can bring this 2x squared to join this one so that you have 2x squared. Remember, if it crosses the sign of inequality, the same just as the equation, it will change to minus 2x squared. And then we have minus 6x plus 5x. Then this minus 15 is the constant. We'll move it to this other side. Because it's negative, when it crosses the inequality sign, it will change to 15. And we can see that 2x squared minus 2x squared will be 0. Minus 6x plus 5x, we have minus x, less than or equal to 15. And of course, we are looking for x, not minus x. So is either we multiply both sides by minus 1 or divide both sides by minus 1 so that this minus will go. Now, here we have a slight difference between this and equation. Whenever you are multiplying by a negative sign or dividing through by a negative sign, I repeat, whenever I am multiplying through by a negative number or dividing through by a negative number, this inequality sign turns. If it is greater than, it will turn to less than. If it is less than, before it will turn to greater than. So if I multiply this by minus, that is times minus 1 times minus 1, that we minus 1 times this, we change it to x, and this will no longer be less than or equal to but greater than or equal to 15 times minus 1 minus 15. So our answer is x is greater than or equal to minus 15. Why did we multiply through by minus 1? Because what you have here is minus x and we are looking for x. Whether it is multiplication or division, once you are multiplying by a negative number or dividing by a negative number, the inequality sign turns. It changes. It's not applicable in addition, it is not applicable in subtraction, only in multiplication and division. So you can see how we're able to manipulate that. Let us look also at this question. The sum of twice a number and 15 is less than thrice the same number minus 9. What is the number? We say solution, let the number be x. So if we say the sum of twice a number and 15 is less than, this is less than, thrice the same number minus 9. What is the number? You see, we have created an inequality with this. So what did we say we do? We collect like terms. So we can move this 3x to come and meet 2x here, so that we have 2x minus 3x is less than minus 9. We move this 15 to come and meet minus 9 here. It becomes minus 15. 2x minus 3x will give us minus x is less than minus 9 minus 15 will give us minus 24. And of course, we cannot leave it like this. We have to multiply both sides by minus or divide both sides by minus. Let's divide this time around. divide by minus 1, divide by minus 1. When you do that, minus will cancel minus, minus will cancel minus, and x will be, because we are dividing through by minus. Remember I said when you are multiplying or dividing through by a negative number, the sign changes. X will be greater than 24, and that is it. So having known that, let's look at what we call number line in inequality. Number line, we know in our number line we have something like this, where you have a mid number 0, we have positive integers 1, 2, 3, and so on and so forth. Then by the left we have negative integers minus 1, minus 2, minus 3, and so on and so forth. So towards the left we have less than, lower numbers, and to the right we have higher numbers. So that is what we call number line. So how do we represent inequality in number line? If for instance I get x is greater than 2, in a number line what I will simply do is to draw a line. Of course, identify 2, identify one or two numbers greater than 2. Of course, I can equally identify 1 or 2 less than 2. So, but at 2, I will indicate using a circle, because that is where this value is. Indicate using a circle. Then greater than, numbers greater than 2 are 3, 4, and so on. So I will draw an arrow from that 0 and point it towards the direction of numbers that are greater than 2. You can see this is how we represent it. 2 greater than 2 is this direction. Then if I have, for instance, x is less than 3, what do? I said I will identify that number 3. I can write 1 or 2 greater than 3 and write 1 or 2 less than 3 in that order, just as it is in the number line. Okay, this is 3, 2, 1, 0, 4, 5. So I will on 3 put a circle, and then less than 3, because numbers less than 3 are these other numbers this way, so I will put an arrow in this direction. This is how you represent less than in a number line. What if it is x greater than or equal to 5? What if it is x greater than or equal to 5? I will identify 5 in my number line. Of course, 6, maybe 7, then 4, maybe 3, and in that 5 I'll put a circle. Greater than is this other way, so I'll put an arrow just like I did here. But what is the difference between greater than and greater than and equal to? Because there is equal to in this one, we are going to shade this circle. We are going to shade it. This is an indication that this is greater than or equal to. This is an indication that this is just greater than. There is no equal to. If it is less than, we will say if I have x less than or equal to minus 2, what am I going to do? In my number line, I will identify minus 2. Of course, greater than minus 2, you have minus 1, you have 0, and then less than minus 2, you have minus 3. You can say minus 4. Then on minus 2, I'll draw this circle. And because it's less than or equal to, my arrow will point towards the less than. And because of the equal to, I will shade the less than. That is how you identify that. This is greater than, this is less than, this is greater than or equal to, this is less than or equal to. That's simply how we represent in a number line. Then what if it is a number that is not an integer? If it is a number that is not an integer, there is nothing different. If it is greater than, let's say, 2.3, okay? This is 2, this is 3. 2.3 is between 2 and 3. So I will put my circle between 2 and 3. And still do the same greater than 2. You see that? It is not in 2, it is not in 3. It's between 2 and 3. That place where we think 2.3 will be. If we have 3.5, for instance, less than or equal to 3.5, the same thing I am going to do. I'll go to 3.5. This is 3, this is 4. 3.5 is the midpoint between 3 and 4. So I'm going to draw a circle there. Less than is this way. Because it is less than or equal to, I am going to shade it. So this is how we identify or we represent inequality using a number line. So we have this other question. What is the range of values of x for which 2x minus 1 greater than 3 and x minus 3 less than 5 are both satisfied? What we just need to do is to solve them separately and get the range of values, then put it together. Okay, if we solve this first one, we have 2x minus 1 greater than 3. What we said is that we're going to collect like terms, so this minus 1 will cross to meet 3, so that we have 2x greater than 3. Because it crosses, it becomes plus 1. So we have 2x greater than 4. You divide both sides by 2. 2x divided by 2 is greater than 4 divided by 2. 2 cancels 2, and x is greater than 2. This one did not change because there was no negative number. Okay, so here we solve the second one. Here is x is greater than 2. The second one is x minus 3 is less than 5. Okay, so we move minus 3 to join 5. So x is less than 5 plus 3. X is less than 8. So how can we combine this? Now, if we want to combine two inequalities, two of them are going to face the same side. Is either you change this greater than to less than because this is less than, so that both will be less than, or you change this less than to greater than. But I prefer turning greater than to less than. Now, if x is greater than 2, it means that 2 is less than x. That is, if I say 2 is less than 3, that means 3 is greater than 2. So I can, instead of writing it that x is greater than 2, I can write it that 2 is less than x. I have not committed any crime. Because if this is greater than this, that means this is less than this. So x is less than, my 2 is less than x, and the same x is less than 8. So putting it together, I'll write 2 less than x, 2 less than x, then x less than 8. So we have 2 less than x less than 8. So the range of values is this. So if I am to represent this in a number line, I have 2, I have maybe 4, 6, 8, 10, 0. So if I have this one is 2, this one is 8. You can see that. Then I will now join them together because 2 is less than x and x is less than 8. Like I said here, x is greater than 2. That means 2 here greater than is this way. And here x is less than 8. 8 less than is this way, and they will meet, and you have this kind of number line. So the range of values is between 2 and 8. Numbers greater than 2 but less than 8, that is 3, 4, 5, 6, 7 if we are referring to integers. So that is how we represent this. This is a range of values now represented in a number line. There will be no arrow because it is a range. So this is it, as we can see how that has been represented. If it is, let's assume this is less than or equal to. If this is less than or equal to, that means this one is going to be shaded. This one is going to be shaded, but it is not. So that is why both of them are not having equal to. That is why it is both are hollow. You can see that. So let us also look at this. Express the inequality 2 minus x less than 8 less than or equal to 9 minus x in the form a less than x less than or equal to b, where a and b are both integers. Just like we did just now, we are going to divide this into two inequalities because you can see two inequality sign in one. So we are going to separate it from here as one and from here as another. So we are going to have 2 minus x less than 8, and we also have 8 less than or equal to 9 minus x. So these are the two inequalities we are going to have. So we solve them separately. 2 we cross to go and meet 8. So we have minus x is less than 8 minus 2. When 2 crosses, it becomes negative. Minus x is less than 6. And because this is minus, you multiply through or divide through by minus 1. So we have minus x. If you divide by minus 1, this will change to greater than. So we have 6 divided by minus 1. So x is going to be greater than minus 6. Okay, the sign changes because we are dividing through or multiplying through by my negative number. So here again, x will cross here to become from minus x becomes positive x is less than or equal to 9. When 8 crosses, it becomes negative 8. So we have x is less than or equal to 1. So here, s is greater than minus 6, s is less than or equal to 1. And I told you that both of them should have the same sign. So the same direction of sign, either greater than or less than. So I'm going to turn this to less than. So it is going to be this way. Minus 6 is less than x. So if I put them together, I'll have minus 6 is less than x. And the same x is less than or equal to 1. You see it's now in this form, where a is minus 6 and b is 1. Then x here. They said it should be in this form, and this is what we have achieved by doing that. So that is it. So let's look at this also. State the range of values of x represented by each number line below. Before we solved and represented in a number line. What if you are given a number line to now state the inequality? So I told you, if you look at this, what you just do is to write these two values, minus 1 x and plus 3. Then what will be in between here will be determined by this. So this is going to be, because this is shaded, it's going to be less than or equal to. This is shaded, this is less than or equal to. And that is it. Here we do the same. Here this is 2, this is 6, this is x. Because it is not shaded, we have less than. Okay, very simple. Here this is minus 4, this is 3, and then x. This one is shaded, so it will be less than or equal to. This one is not shaded, so it's just less than. Then here you see that these two circles were not combined, they were not joined, so you cannot state them together using and. It is either this or that. So we can, because this is now less than, it means x is less than or equal to, because it's shaded, 4, or this is greater than, x is greater than 7. This one is not equal to because it's not shaded. X is less than or equal to because it's shaded, 4. Less than or equal to, it is going towards the left. And this is going towards the right, so x is greater than 7. These two cannot be combined. X is either less than or equal to 4, or x is greater than 7. So the two of them x cannot be both less than 4 and greater than 7, because a number that is less than 4 cannot be greater than 7. That is why we cannot combine these two. So, but this is the representation. This is the representation of the inequality from the number line. So in our next class we are going to look at inequalities, linear inequalities of two variables. You look at all we sort of dealt with one variable, we're just dealing with x. So what if we have two variables, x and y? How do we manage it? We'll see that in our next class. Thank you.